Hello students, at the last turn we came to know that we will start our study from coordinate systems, and further we find that there are three coordinate systems: Cartesian, cylindrical and spherical, and in every case we are interested to find the variables, range of variables, and three different terms, that is differential length, differential surface and differential volume in all three coordinate systems. And apart from these, we were interested to find the interrelationship between coordinate systems and the transformation from one coordinate to another coordinate system. So these all terms we are interested to find for all. So let's start from Cartesian coordinate system. So in case of Cartesian coordinate systems, there are three coordinates. You can say there are three directions: x, y and z. They are 90° apart from each other. The angle between x and y is 90°, y and z is 90°, and z and x is 90°. In this way, they are orthogonal, and any vector in the direction of x is indicated by unit vector ax, ay, az. Ax, ay and az are unit vector in the direction of x, y and z respectively. So in this case there are three variables. The first term, that is variable. In these coordinate systems, suppose we assume any point P and we want to mark it, then it will be x, y, z. We can mark it like this. This is the point P. So the three variables are: first variable is x, second is y, and third is z. There are three variables. In terms of coordinate, we can say x, y, z, and their range. This is the positive direction of x, in the direction that is indicated by x, unit vector, and this is the negative direction of x. So x can vary from plus infinity to minus infinity. From minus infinity to plus infinity. So range of x can be minus infinity to plus infinity. Similarly, for y, the range of y can be minus infinity to plus infinity. Similarly, z can vary from minus infinity to plus infinity. So the variables in case of Cartesian coordinate systems and their ranges are presented here. They are very basic and that is very simple. We all are familiar from these. Now the next thing is the position vector. Assume this point as a reference, and this is our point of interest, and we are interested to find the position vector OP. Then OP can be written as any vector. We know the final position minus initial position is called displacement, or the position vector can be represented from final minus initial length. So initial point is our origin, that is 0 0 0. Coordinate of this can be defined as 0 0 0, and coordinate of P is x y z. So OP position vector can be written as final x minus initial x in the direction of x. So that we can say this point. This point we move in this direction up to here, then we move this direction up to here, then we move this direction up to here. So this to reach up to this position, the point of interest, we can move in this direction. Okay, the known path is only this. So this is final x minus initial x, that is x minus 0, in the direction of x, that is ax, plus, now we have to move in this direction, that is final y minus initial y. Y at this is 0 and y at this point is y, because it is indicated from here. So final y minus initial y in the direction of y, plus final z minus xy plane, the value of z is 0. So the final z minus initial z in the direction of az. So our position vector will be x ax plus y ay plus z az. So in this case we find the position vector in Cartesian coordinate can be written like this. Now the thing in which we are interested now, we came to know these two. The thing that is in point of interest is differential length, differential surface and differential volume. So for let's start from differential length. Differential length. Differential length. For differential length, we will assume any object like this. Okay, this is our object. For simplicity, indicate them okay. Now this is x coordinate, this is y coordinate, this is z coordinate. So if we are interested to know about differential length, then it means if we move a small distance in a rectangular coordinate system, then how we can express that vector? To cover full object. So to cover the full object, the length, small distance, how we can express in vector form. So let's start to understand the finding of differential length. To cover the full object, what we can say, we should move from A to F or A to G. Okay, so take anyone, assume A to A. No, moving from A to G is not sufficient. Move from A to F to cover full object. So AF can be written as AB plus BC plus BF. AB plus BC plus CF. So AF can be written in this form, and AB can be written as, this is the movement in the direction of y. So the full length is y, the part of that can be written as dy. Okay, either we can say this is the initial point, this is the final point minus initial point is the small movement we are talking about now. So this is dy in the direction of ay. So how we can represent AB? dy in the direction of ay. What's about BC? BC can be written as, see, this is the beginning of the Z, this is the final of the Z. So final Z minus beginning Z, initial Z will be small dz. So we can say dz in the direction of Z. Similarly, CF can be written as dx. Forget about sign, we are moving opposite to the positive x. Anyway, don't consider sign in differential length of the Cartesian coordinate system. Just consider the length. So CF can be written as dx in the direction of ax. Or what we can say, you can understand in another way. If you don't want to ignore the sign, then this is the negative of x. So final x minus initial will be some minus dx, and the direction of unit vector will be ax with negative sign. So it will bring you positive. So anyway, so this is the AF. Now this is the small length, can be written as differential length, dx ax plus dy ay plus dz az. So this is our differential length in case of Cartesian coordinate system. Hopefully it should be clear to all of you. So to cover full object, we start from any point and we covered full object. The length covered, that is called differential length, can be represented like this in case of Cartesian coordinate system. And the next thing is differential surface. So differential surface consider the object. There are how many surfaces? 6. The first one, the second one, and consider the top. How we can make the top surface? Okay, good. So this is third surface. This is compare from here. this is relate from that A, B, C, D, this surface, and this one is B, C, F, E, this surface, and this is the top surface. You can say, you can take anyone, but for consideration now we are taking C, D, G, F, these three, and another three are just another side of the cuboid. So there are six surfaces, and we know that surface is a vector quantity, and the direction of that vector will be out of the surface. So in this case, the out of the surface will be like this, and in this case, the out of the surface will be like this, and in this case, the out of the surface will be like this. So the direction of the differential surface will be coming in this direction, outward. I don't have any object to show you right now. Anyway, to outward, and the direction of this surface will be this one, and the top will be like this. So all are presented. Three of them are presented. Next three will be just opposite to them. Now, if we have to find the area of this, then we came to know that this is the dy x, y, z, this is dy, and this is dz. And what's about this? This is dx and this is dz. And what's about this? This is dy and this is dx. Okay. So what's about area of ABCD? The area of ABCD will be, you can say, area 1. Yeah, okay, just D is, if you have to represent, then what you can say, area of this, that is dy in the direction of AY and dz in the direction of vector quantity. So cross product will be there and the outcome will be a vector, and dz in the direction of AZ. Now multiply this, dy cross dz. Okay, so let's try to understand one concept here. We know right hand thumb rule, or we can say screw rule, that cross product of cross product of x and y will give you, from x to y, the direction of thumb will be your the next vector direction, the resultant vector direction. So the cross product of x and y will give you the direction of z, and similarly the cross product of y and z will be x, y and z will be x, and in this way z and x will be y. So if we want to present this, then we can say 120 degree y, 120 degree z. The product of x cross y will give you this z direction, y and z will give you x direction, z and x will give you y vector. So in this way we can find area vector from here. So let me erase this, then we will talk next. Okay, so the ds will be dy consider it small, dy and dz, the output will be in the direction of x. So dy dz and the area of the resultant vector will be in the direction of x. Similarly, the area vector for this can be written as dx and dy in the area, this will be area, and in the direction of dy. Dx dz in the direction of y, and the third area vector will be dx dy, or you can say dy dx in the direction of az. Okay, so in this way you find out the area vector for this surface and this surface. So these are coming out from the object, out of the surface. So this direction has been taken positive. If you consider the this as positive, then opposite to that will be negative. So it can be written as positive plus minus and plus minus. Both can be written for this. So this is our differential surface or differential area. Now relate this and this. What we can find? If we know the differential length, then it is very simple to find the differential surface. Check here. Dx multiplied with dy, just write differential length for relating dx ax dy ay plus dz az. To relate, to find the vector differential vector from here, multiply this, what you will get? Dx dy, and the product of these two will give you in the direction of az. And see here, dx dy az. So multiplication of these two and these two with the application of the cross product will give you the area, differential area. So what we want to conclude from here, if we know the differential length, then it is very easy to find the differential surface. No need to work for differential surface like this. Just this is for your understanding. And now if once you came to know the differential length, just multiply the these two and find the differential surface, these two find the differential surface, and these two find the next differential surface, and that will be for top and bottom, both of them, according to the explanation given here. So in this way we are familiar from differential surface now. Now let's come to differential volume. Differential volume, this is the simplest one. You don't have to do anything else. Just what you have to do to find the volume of this, what you have to do, this length multiplied with this length multiplied with this length will give you the volume, and that is not a vector, that is simply scalar, so don't worry about that. It is simple, it will be very simple. So differential volume will be dx, dx, dy and dz. And if you know the differential length, then from here you can find the differential volume just multiplying all of them. Keep in mind how we can find the differential surface and differential volume from differential length. That will help us a lot in case of different coordinate system. So differential volume is just multiplication of these three.